Hi, everyone. I'd like to thank you for attending today's Clara Filter webinar. My name is Peter Evans. I'm the Regional Director at StormwateRx. I also have Rob Chapler, our Engineering Manager, with me to answer any technical questions you may have for him during our question and answering session. It's my pleasure today to introduce our new stormwater filtration product called the Clara Filter. But before I begin my presentation, I want to let everyone know that StormwateRx is now part of a much bigger family of companies. Our parent company, the new Terra Group, is truly redefining water, wastewater, and stormwater treatment. As a group, we are expanding the boundaries of modularity, and while serving a global customer base, Terra is truly the leader in fueling our industry with clean water solutions. StormwateRx is proud to be a member of the new Filterra family of companies. Today's agenda will consist of the following topics. First, I will describe to you what the Clara Filter is, its main purpose, and the individual components. I'll describe to you how the treatment system works. Thank you. I've lost my screen. Sorry. That's all right. I don't need it. I will describe to you how the treatment system works, the flow path the stormwater takes through the filter, the media built inside of the Clara Filter. I will speak to a number of the unique features the Clara Filter has and the benefits each of these can offer you and your industrial site. I'll describe what kind of sites the Clara Filter is, particularly well suited for, and what engineering design information will request of you to integrate the Clara Filter into your site. I'll briefly take you through our pilot testing program, the TSS performance we obtained during our evaluation period. I also will share with you our sizing table, treatment flow capacities, and provide information on overall footprint and capture capacity. Finally, I'll wrap up the webinar with our installation and operation maintenance requirements, and then move on to our question and answering session. So what is the Clara Filter, you may ask? The Clara Filter is a high-rate filter that specifically targets the removal of coarse and fine TSS or sediment in your stormwater. The Clara Filter utilizes an affordable inert media with high flow characteristics and TSS capture rate. Clara Filter is easily placed and functions as an offline configured BMP. It is sized to treat the design storm, or commonly referred to as the water quality flow rate. Thank you. I'll just move on to the slide here if you don't mind. Thank you very much. The Clara Filter possesses a unique design that consists of 4 distinct and separate chambers, with 2 chambers acting as our filtration chambers. The filtration chambers have 2 filtration flow paths, a downward flow filter, and alternatively, a second filtration chamber in an upflow configuration. The Clara Filter is a concrete structure that can be placed below ground, but we can also accommodate sites who wish to install the Clara Filter in above ground configurations. So what is the Clara Filter? There are 7 major components that make up the 4-chambered Clara Filter. Number 1, located in chamber 1, is the inlet pipe where untreated stormwater enters the Clara Filter. Number 2 is our internal bypass weir that separates chambers 1 and 4. Number 3, which you see on the top right-hand side, is located in chamber 4 and is the outlet piping, where treated water exits the Clara Filter. Number 4 is the shrouded treatment inlet window that passes untreated water quality flow rate stormwater into the first filtration chamber. This is referred to as chamber 2. Number 5 is the outlet orifice or upturned elbow, and is where the treated stormwater leaves the second filtration chamber and enters chamber 4. Number 6 is the first downward flow filtration chamber. It's that chamber number 2. And number 7 is the second upflow filtration chamber, which is chamber number 3. My next slide depicts how the stormwater passes through the Clara filter. Beginning at the lower left-hand side of the diagram, untreated stormwater enters the structure via a piped inlet or graded inlet. Inside chamber 1, heavy settleable solids are removed by simple gravity separation. The stormwater then passes through the shrouded treatment opening and enters chamber 2, the first of 2 filtration chambers. Stormwater passes downward through the inert media, capturing sediment, oils, and other insoluble pollutants. At the bottom of this chamber, stormwater passes through a large cutout located at the bottom of the vault spaffle wall that separates the 2 filtration chambers. Stormwater passes into chamber 3 and moves in an upflow direction, capturing finer solids and sediment through our media. Finally, treated stormwater enters the upturned elbow and discharges into the final chamber number 4. This is where the outlet piping is located and is where we can place an optional integrated pump to direct treated stormwater out of the Clara filter, either directly to your outfall or to downstream treatment BMP. Clara filter has been sized to meet the offline water quality flow rate or design storm through the filter media and all its orifices. Peak flows over our internal bypass weir. Wanted to point out some of the features and benefits of the Clara filter. Mainly, it has the feature of a very high flow capacity media and loading rate, which keeps the overall footprint of the Clara filter to a minimum. The Clara filter is a precast concrete structure, and with numerous precasters across the country already using our Clara design, we can cut lead times and minimize freight costs when delivering the Clara filter to you. The Clara filter possesses a high TSS removal rate and can act as a standalone BMP or be used as a pre-treatment device for any downstream stormwater treatment system. The Clara filter can help facilities reduce the cost of maintenance associated with end-of-pipe treatment systems. Because Clara filter is positioned offline, scouring of pre-settled solids is all but eliminated. The advantage of having an internal bypass weir is that these larger storm events can be far better managed than your typical online configured BMPs. The Clara filter uses an inert high flow rate media. This media is inexpensive, so cost of replacement is kept low. We specifically designed the Clara filter with ease of maintenance in mind. Simple routine and full maintenance activities can be scheduled as needed. Finally, one of the nicer features, I think, of the Clara filter is that we can add, as an option, an integrated pump into chamber 4. The pump is sized to direct the water quality flow rate out of the filter bay to almost any treatment BMP, like our above ground equip, or directly to your outfall. The integrated pump also eliminates the need for additional concrete structure, saving you installation time and costs. I wanted to point out some of the site characteristics and considerations that we take into account when selecting a Clara filter. It's our contention that the Clara filter is best suited for sites with high TSS or sediment loading. This loading could be due to the presence of partially or unpaved surfaces, or even sites that have broken asphalt or pavement. It's also well suited for total impervious sites that may have a high level of small particulate matter, such as tire scrub and brake dust. Clara filter can be integrated either during the design phase of the project or be installed as a retrofit into existing sites. Clara filter can be placed either below or above grade, depending on your site conditions or site constraints. The Clara filter is commonly placed upstream of your compliance point, which truly makes Clara filter a simple site integration. Some of the design information that we would ask of the site manager or consulting engineers are as follows. We require that the design and peak flows are provided to us, as this establishes really the overall Clara size, but also the internal bypass weir and internal dimensions of the vault. If this is unknown, our engineers may be able to assist you to establish these critical values. We ask that you provide the drainage pipe size and material of construction, as this will establish the core size when being manufactured at the precaster. Another item would be the top of grade, or as we refer to, rim to invert elevations. This establishes the core's locations for the inlet and outlet piping, but also the overall vault depth. Total top slab load requirements or traffic rating would be required if the Clara filter will experience being driven over. So it'll be clear that it might be an HS20 or an HS25 type loading. Could be even higher for some of the port locations. Finally, we had asked if the site experiences any groundwater influences. If so, buoyancy collars may be needed to establish proper vault footing. To talk about our pilot and performance, the Clara filter went through a rigorous testing protocol to enable us to provide a simple sizing table, which I'll show in the next slide. It also allows us to provide you with an expected TSS removal rate or efficiency. As seen in the lower photo, our 10-gallon-a-minute pilot was set up in our Portland lab and run at a number of flow or loading rates. We found that 10 gallons a minute per square foot of surface area was optimal, which is a very high loading rate for any stormwater treatment filter. We observed during our pilot a TSS removal efficiency as high as 91% and as low as 41%. The median removal, though, was at 71%, which is truly outstanding for a stormwater filter with an inert media build. We decided not to run particle size distribution pairs during the pilot, as these results are often incorrectly interpreted and therefore applied. But this next slide really speaks for itself. As you can see, the inert media does an extraordinarily good job at capturing TSS, oils, and other pollutants. This photo was taken looking down onto the filter. This is loading that would have otherwise ended up in your outfall or downstream to your treatment BMP. Clara filter sizing. The basis for sizing the Clara filter is strictly flow-based. This table depicts the model number associated with each treatment flow rate. Again, I want to emphasize that the flow rate shown in this table is the offline water quality flow rate, not the peak flows. Please make note of this important value when choosing a Clara filter size. The sizing table also provides information on the overall vault footprint and the expected sediment storage capacity before the Clara filter would need to be cleaned. Clara filter installation. Installing the Clara filter, like many underground vaults, are quite routine for our contractors and require very little time to offload and set in place. The contractor scope includes offloading the Clara filter, excavation of the hole, setting of the Clara filter, inlet and outlet pipe connections, backfilling, and final grading up to the unit. We'd like construction activities to be completed before we load the media and commission the filter into service. That said, we'll have trained StormwateRx staff on site during the installations to assist the contractor and end user. My last slide addresses the O&M for the Clara filter. As with any BMP today, inspection and scheduled maintenance is critical for long-term operation, functionality, and pollutant removal. Inspection of the Clara filter is similar to our equipped filter. We would ask that you observe and note the level of TSS buildup on the filter surface in chamber 2. If inspection is done during the actual operation of the Clara filter, please note if the filter is showing bypass or not. This would also be a very good indicator that the Clara filter needs either routine or a full maintenance. There are really only two types of maintenance activities associated with the Clara filter, the routine and the full. The routine maintenance removes and replaces approximately 6 inches of inert media from chamber 2 only. This activity removes the sediment buildup that was captured on top of the media and will help reestablish the filter's flow capacity. A full maintenance requires both filtration chambers to be completely cleaned out of the inert media and reloaded with new media. This activity will establish the filter's full flow capacity, almost as if it were like new. Maintenance activities with the Clara filter will require a Vector truck and crew. Because access to the vault is rather simple, the expected time on site will be kept at a minimum. We anticipate less than 2 hours by the crew for a full maintenance to be completed. Lastly, and more importantly, disposal of the inert media should follow any local, state, or federal guidelines. Well, that about wraps up our Clara Filter webinar. I want to thank all of you for joining us today and learning more about our new innovative filtration product. Please let us know if you feel the Clara Filter is a system that could find good use at your facility. We will be placing another poll question, as you can see, for you to answer. Please take the time to answer these poll questions for us. As of now, Rob and I are now open for any questions you may have. I believe you can post your questions in the Q&A tab. Thank you very much, everyone. We look forward to your questions. So there's a couple of questions. Here's one from Brett Holmes. Thank you, Brett, for joining us today. As you can see, Rob is asking us, any testing performed for approval certifications from NJCAT or Washington Department of Ecology for fine sediment or nutrient removal? Brett, no. This is a very new product. We have not yet entered it into TAPE or even into NJCAT. Our plans are to do so. Brett, you had another question. How many current installations and what are the site types, residential, commercial, municipal, or industrial? Brett, we primarily or specifically do industrial installations and industrial stormwater treatment. We have one sale currently. The vault is being made for a recycling facility in Seattle. Patrick, what is the cost of the media? You could maybe answer that, Rob. I don't know what the cost, if you want it per cubic yard or what would that be the cost, Rob?
Well, so I don't have it broken down by cubic yard. We can follow up with you, Patrick, on kind of pricing of basically just the maintenance cycle and expected lifetime costs. We do have pricing broken out per model size, so it kind of depends on.
All right. Well, thank you, Rob. Steve Fisher, thank you for joining us today. You had a question about how much efficiency is lost after the 6-inch media is removed. I guess I didn't make myself clear. Once that 6-inch layer of media is removed, it's replaced with new media, Steve. So there will be very little or no loss in pollutant removal efficiency or TSS removal efficiency. And Travis, he had a question here. Thanks, Travis, for joining us again. Have you tested the pilot with TSS loading above 100 milligrams per liter? Rob, you ran the pilot. Can you please address that question?
Yeah, so no, we did not run with any influent TSS concentrations above 100. We unfortunately only, we could only get what we got during the pilot testing, and I think the highest was in the 90s, but we did see good performance there. The expectation would be that, treating over 100 milligrams per liter shouldn't be an issue. So it'll just be a faster rate of solids loading into the filter. But the idea, as Peter said, of 100 milligrams per liter or above, I think would still be a good fit for the Clara filter.
Hi, Michelle. Thank you for your question. Can the pricing for size be posted to the handouts? Unfortunately, no, because that is public information. We don't, number one, don't want our competition to know our pricing. But number two, each Clara filter, depending on depth and what options you might want available, it would be developed, per project. So if you have something in mind and you know certain aspects of the site, then we could give you a budget estimate at least.
Hey, Peter.
Yes.
I'd like to interject. If you go over to chat, there's a lot of good questions in chat. Sharon Simpson, Monty Ridenauer, and David Kadzorski they're offering up some questions.
Okay. Can I just get to Steve Fisher's question here? How is oil removed without losing media? Can you repost that, Steve, if you don't mind? Thank you. Can you see that question, Rob? Maybe you can answer that question. How is oil removed without losing media? I don't think oil.
Yeah, sure.
There is no loss.
Yeah, so we'll get oil removal both from adsorption to the media, as well as it being trapped in the second and third chambers of the filter, just by phase separation, essentially. So the system is not exactly designed for high capacity oil removal, but it will sequester oil within the system. And so the removal is just, during the maintenance procedure, when the water and media are removed, you'll get that trapped oil out as well.
Hi, Sharon. I wanted to maybe address your question in chat. It says, thank you for joining us too, Sharon. I noticed only loadings or TSS under 100 milligrams per liter is shown. The site with high TS loading sees sometimes 400 plus. Was there any testing with this type of loading? No, there wasn't. Like as Rob mentioned, we got what we got in terms of the stormwater that we ran through the pilot. I would suspect that sites that had a TSS greater than 400 would require more maintenance. David, thank you for joining us. Are different medias available to target specific pollutants such as zincs? At this time, David, no. And maybe you might want to elaborate on that a little bit, Rob, further. But at this point, we have tested one media and one media only. We would certainly see
right. So the media,
insoluble zinc.
The media is intended to a high hydraulic capacity, and so for that reason, there's as you know, there are many different filtration medias available. Some that are sorptive and some that are inert. In this case, because we're expecting a high level of solids loading, sorptive media doesn't really lend itself well for that. So we are sticking with, in this case, removal of solids and any pollutants that are associated, non-aqueous phase pollutants. So that might be, metals that are in the solid phase, even nutrients that are in the solid phase. So in general, yes, we do expect that there would be some level of zinc reduction if there's zinc associated, non-dissolved zinc, as there typically is some portion. But in general, yes, just solids removal.
Hi, Sharon. You had another question with regards to maintenance. You asked, how long do you need regular maintenance? I think that would be site specific. It would certainly be dependent upon the suspended solids entering into the Clara filter from that site. So as with any BMP, it's hard to predict the length of time or the maintenance interval without actually installing it and running it. And Monty had a question, Rob, for you. What is the media thickness for the downflow and upflow chambers?
Media thickness is about 2.5 feet.
Thank you. Sharon asked, without the media being under pressure, how do you stop blinding and the water going through to bypass? Would you like to answer that?
Sure. We do get some a small degree of pressure, just the hydrostatic pressure of surcharging water in the system that forces water through. As I suppose that's basically how any gravity-based system works. But you're right. At a certain point, the media does blind, and then water will go into bypass even for events that are within the design capacity of the system. And so it does require some occasional inspections just to make sure that it's processing the water that it's supposed to. So there should be some wet weather inspections occasionally, and as well as some dry weather occasions when you can actually inspect the media itself to gauge the solids loading. So we have a operation and maintenance manual that details those procedures. So it should be fairly simple, but it does require just occasional inspections.
And Sharon asked another question here for you, Rob. What is the media?
The media is, without getting too specific, the spec is proprietary, but it's just an inert media with a very high hydraulic conductivity. And I'll leave it at that.
And then Steve Fisher had another question. How was the sediment removed from the first chamber after settling? It's removed via a Vector truck. And we're talking about possibly a routine maintenance being the first 6 inches, Steve. That water would be vectored out, or that sediment would be vectored out to a depth of 6 inches, and then new media would be replaced. Hope that answers your question. Adam, thank you for joining us. What is the average life expectancy of the media? That's a good question. I would suspect the average life expectancy would be about 1 year. I would recommend, or I would think that others would too, that the Clara Filter doesn't exceed 1 year in operation without a full maintenance. We have more questions. You could either post them in the chat or the Q&A.
I see another question pop up in chat. So Sharon posted another question. What is the depth of loading in chamber 2 in order not to have loading?
I'm not quite sure how to answer that. I don't know exactly what is being asked. I'm sorry, Sharon, can you maybe put that a different way?
I could, let me see if I can turn on Sharon's microphone. If I see her on the list, I don't see her on the web joining panel, so.
Oh, she's clarified. So the depth of loading in chamber 2 in order to not have bypass. Okay, well, not sure I understand, but maybe it's this. So you might be wondering what available, say, maybe freeboard is there, excess capacity as the system starts to accumulate solids so that it doesn't just go into bypass immediately once it starts filtering sediment out. So we do have a few extra inches of what you call freeboard to account for that additional head loss as the media starts to collect solids, begins to occlude or plug, so that we have that available excess driving pressure to force water through even as the media is getting dirty. So it's a few inches. It's certainly more than is necessary when the media is clean. It's sort of a balance. We don't want it to be too much because, the way to generate that additional head is by surcharging the water upstream. So we want to, make sure that we're preventing excess flooding of upstream infrastructure.
Thank you very much, everyone, for joining our webinar. Please go to our website at www.stormwaterrx.com. Thank you.